Hello and welcome to this third tutorial in the series on trigonometry. And you see I'm still struggling to spell this word. In this tutorial I want to talk about calculating the areas of triangles. And we'll see that there's a formula that we can easily derive actually for the area of a triangle involving the sine of one of the angles and the length of the adjacent sides. So let's start by reminding ourselves of the formula for the area of a triangle, which is half base times height. And let's just remind ourselves why that's true. If I draw a rectangle of height h and base b, then the area of this rectangle is self-evident to be the base times the height. And let me imagine now deforming this into a parallelogram. So if I sort of draw the ghost of that rectangle there, you see it has the same height and base, but now what I want to do is slant it and make a parallelogram. And the base of this parallelogram is still b, the height of the parallelogram is still h. And you see that the area we've lost here is precisely the same as the area we've gained there. And so the area of this parallelogram is still just base times height. And now if I bisect this parallelogram with a diagonal and look at, say, this triangle here, then the area of that triangle will be precisely half the area of the parallelogram by symmetry. And so the area of the triangle will be a half of the area of the parallelogram, a half base times height. So if you have a triangle and you know its base and you know its height, the height perpendicular to the base, then you have this simple relationship. Now let's imagine that we have a triangle for which we do not immediately know the height. Let me try and draw it similar to the one I've just been dealing with, but a bit bigger. Let's label it. Let's call this B here and little a and little c. Now I'm going to use A, B and C for the vertices, and I apologize if there's going to be possible confusion between using this capital A for a vertex and A for area here. So let me just maybe write this as AR for area so we don't get confused. Right, so let's imagine we know these two sides A and B, and we know this angle C, and the question is, can we determine the area of the triangle? And the answer is yes, we can, because the area of the triangle is a half the base, which is the length b, times this height h. And do you see that by bringing this line down to define the height, I've made a little right angle triangle here. And so in this right angle triangle, I can use my definition of the sine of angle C. And we see that the sine of angle C is the opposite over the hypotenuse. The opposite is h, and the hypotenuse in this right angle triangle is the side opposite to the right angle, and that is side A. And so rearranging this formula, multiplying up by A, I have that A times the sine of C is equal to the height of the triangle. And so we have this nice rule then that the area of a triangle is a half times the base times h, which is A sine C. And let me just rewrite this in a way that's more familiar. I'm going to just reverse A and B here. So a half AB sine C. So if you know an angle and its two adjacent sides, you always know the area of that triangle because you just multiply those adjacent sides together, multiply by the sine of that enclosed angle and divide by 2, and it gives you the area. And we see it's really directly related to the slightly more elementary formula for the area of a triangle that we already knew. So let's just do a couple of examples. Let's just going to make these up here. So here's some triangle. Let's say that I know this angle here is 50 degrees. And let's say that this length here is 5 and this length here is 3. What's the area of the triangle? It would be 1/2 times the product of these two lengths. So it'd be 1/2 times 3 times 5, and then times the sine of that angle, sine of 50 degrees. Now, nearly always when you're doing trigonometry with sine, cosine and tangent, you'll need to use your calculator to calculate sine, cos or tan. These are functions which have been tabulated in the old days in books and then in modern times stored in the memory of calculators. So let me take 50 degrees, take the sine of that, and then multiply it by 5, multiply it by 3, and divide by 2. And I find that the area of this triangle is 5.745 ... units squared. And with things like this, it probably makes sense to maybe give 2 decimal places. So we have some good practice here with significant figures. We want to just give the second decimal place, and we're just going to round up, therefore, because the next digit is 5 or greater. So to 3 significant figures, or in this case 2 decimal places, we have 5.75. I'll just write units squared there because I don't have any particular units on that triangle. Let's just do one more example. Let's say that we have a triangle where we're told that this angle here is 30 degrees. We're told that this length here is 7, and we're told that the area is, let's say, I'm just thinking on my feet here, let's say we're told that the area is 10 units squared. Can we determine this other length? And let's call this length here A. And of course we can, because the area, which is 10, is equal to 1/2 times the product of these two lengths, so it's 1/2 times 7 times the unknown length, and then multiplied by the sine of 30 degrees. So on the right hand side here, we don't know this length A, but we can work out the rest of it. We have, so if I can display the triangle and my calculator at the same time, we have 1/2 times 7 times the sine of 30 degrees, which is 1.75. And then we have the unknown quantity A. And so by dividing 10 by 1.75, we will determine that unknown length. And we find therefore that A is 10 divided by 1.75, which is equal to 5.71 units. So I've just done 2 examples, one where we have a straightforward calculation of the area, the second where we use the area formula to actually determine an unknown side given knowledge of the area and an adjacent side and an angle. And these are both typical kinds of questions that come up in exams. Just notice that the sine of 30 degrees, when we calculated it on the calculator there, was a simple number, 1/2. There are some special angles where sine, cosine and tangent have particularly memorable values. and I'll mention those in one of the tutorials in this series. So that's areas of triangles. I hope that was helpful, and in the next tutorial we'll be dealing with the sine rule. So I look forward to seeing you then.